So compound inequalities, they involve more than one inequality. When we are talking about an or, we have to think about what it'll do to our graph. And so these or inequalities, not always, but typically they graph opposite of one another. Okay, that's not a rule that they have to, but most of the time that's what happens. So if I have x is less than or equal to -2, the equal to tells me it's a closed circle. If it's less than, which direction does it go? Okay, where's your binder? You took it out of my room last week.
With all my other stuff.
With all your other stuff. Okay, well then you have two notes on notebook paper, I guess. Until you find it and bring it back. Get something to write with. So less than is smaller, so that's going to the left. Or x is greater than 3. No equal to, so it's an open circle. Greater than goes to the right. So when we look at this, it's going two opposite directions. I am not going to worry about the interval notation for these. It becomes a little complicated because they're going two separate directions. So that is not going to be our focus right now. We are just talking about the solution in the graph. So when we solve them, most of the time we have two totally separate problems that we're solving. So we solve each individually, and then we graph them together on the number line. So if I said our problem was x minus 4 is less than -7, or 2x is greater than or equal to 12. So we have two separate problems we're solving. So the first one, we add our 4 over. So x is less than -3. When you go to graph that, would it be an open or closed circle at the -3? Open. And it's less than, so it's going to the left. Then I solve my other problem. So 2x is greater than or equal to 12. So we can divide by 2. So x is greater than or equal to 6. So that would be a closed circle at 6 and going to the right. You do have to have this. Okay, that is the actual solution. The x is less than -3 or x is greater than or equal to 6. So I'm not making you write the interval, but you have to have this. That's the solution, and then we have to draw the graph. Okay, two pieces that I'm looking for on them. All right. Number 2. -3x is less than or equal to 9, or 5 plus x is less than 6. So we have two problems. Remember from last week, if you divide by a negative, what happens? Changes our inequality. That will flip. So -9 divided by -3 is +3. X is greater than or equal to +3. So greater than is going to go to the right. Equal to means we have a closed circle. So we have a closed circle at 3 going to the right. Or 5 plus x is less than 6. So if I'm solving for x, we subtract our 5. X is less than 1. No equal to, so open circle at 1, less than goes to the left. So we have to have x is greater than -3 or x is less than 1. That's my solution. And then we have our graph. I want you guys to try a couple. Try 3 and 4 for me. We have to solve each of these inequalities. So this is like what we were doing last week, or your quiz. You only had one of them. Now we're doing both in one problem. If I want to get the x by itself, the first step is to subtract my 9. So that gives me 2x is greater than 8. Then, if I want x by itself, we have to divide by 2. If I divide by a positive, that doesn't flip my inequality. It only flips if you divide by a negative. So we get x is greater than 4. So that's an open circle at 4. Greater than goes to the right. The other one, we are trying to get the x by itself. So subtract the 10. So we get 5x is less than 0. Divide by positive 5. So since I divide by a negative, it doesn't flip my inequality. X is less than 0. So no equal to is open circle going to the left. So ors don't have to, but typically your graphs are going opposite directions. Okay, if they aren't at the end, then you need to look back and see if you made a mistake. So this is my answer, and there's my graph. You need both parts. Is that okay with everyone? Number 4, what do we do first? Yep, add our 14 over. So that's 7x is greater than or equal to 14. Okay, x by itself, we divide by positive 7. So x is greater than or equal to 2. Equal to is a closed circle. Greater means you want the bigger thing, so it goes to the right. Next one, if we subtract our 5, you get 4x is less than or equal to -8. Divide by 4, so x is less than or equal to -2. Closed circle at -2, less than goes to the left. Again, you have to have the solution and the graph, both parts. Any questions on those? Number 5, we all need to pay close attention to this. Okay, we have 2 separate problems. So that's kind of the key to ORs. We have 2 separate things we are solving and graphing. What would you do first on this one? Okay. So that would give me a -6x. -3 times 1 is -3. It's less than -15. So now to get x by itself, we add our 3. Opposite of multiplying by -6 is to divide, and what happens when I divide by a negative?
Flips.
Flips. So x is greater than 2. Open or closed circle? Open. So we have an open circle at 2. It's greater, so it goes to the right. What do I do on the next one? You can't just drop that negative in front of the x. It's still there. So -x is greater than or equal to 4. So we have to divide by -1, which flips our inequality. So x is less than or equal to -4. Equal Equal to means closed circle, less than goes which way? Left. So we get x is greater than 2, or x is less than or equal to negative 4. Alright, so what we're going to do now, I am going to have you guys practice them. I don't want to teach the next type until I know we have this one down. So, you're going to practice it. You can ask questions, you can check yourself. When you finish, I'm going to look over it. If it's not correct, I'm going to be giving it back to you. So, take your time the first time, make sure you're doing it right.
Tell me about what you were doing the other night. You just asked me out of nowhere. And then it's like, I'll tell you at school tomorrow. We ain't have school.
For somebody else.
I was with
Yeah, I see the person not wanting to know about what was in the